Part 2 of solving second order homogeneous ordinary differential equations with constant coefficients. Part 2. So, we now know that there's two functions, y is a function of x, such that its second derivative minus 5 times its first derivative plus 4 times the function itself makes 0. Do you believe it? Let's find out. I would like you to do a quick check. We're going to do this several times, so we'll call this check 1. Let's check y equals e to the 4x. If y equals e to the 4x, then the second derivative would be, well, the derivative would be e to the 4x times 4. The second derivative would be e to the 4x times 4 again. So the second derivative would be 16 e to the 4x. If you need to, pause and double check my second derivative of e to the 4x. Minus 5 times the first derivative. The first derivative of e to the 4x would be 4e to the 4x. Plus 4 times y, plus 4 times y itself, e to the 4x. And the question is, does all of that truly make 0 as we are claiming it to be? Well, look, you have 16 e to the 4x's here. Here you've really got minus 20 e to the 4x. So 16 of them minus 20 of them would be negative 4 of them, plus 4 more of those e to the 4x, yes, does indeed make 0. Now what about e to the x? We'll call that check 2. So the second derivative of e to the x, of course, is e to the x minus 5 times the first derivative plus 4 times the function itself. Question is, does this indeed make 0? Well, look, e to the x minus 5 e to the x plus 4 e to the x, I hope you see, does indeed make 0. Check. But wait, are you ready for something crazy? There's something even more going on here. Not only do these two functions individually check as solutions to this second order differential equation, but the sum of them also checks. That is, check this out. We'll call this check 3. I'm claiming that y equals not only just e to the 4x, but the sum of e to the 4x plus e to the x is also a solution to the second order differential equation. Check it out. The derivative of this would be 4e to the 4x plus e to the x. The second derivative of this would be 16e to the 4x plus e to the x. So the check would look something like this. The second derivative, 16e to the 4x plus e to the x, minus 5 times the first derivative, 4e to the 4x plus e to the x, plus 4 times the function itself, 16e to the 4x plus e to the x. Does it indeed make 0? Now, I hope what you'll see here is that because we made this combination, this sum of our two functions, we're really just doing the same thing we did back in check 1 and check 2, but just together. Look, 16e to the 4x minus 20e to the 4x plus, plus 4e to the 4x. 16 minus 20 plus 4. Same thing we did here is going to be 0. How about e to the x minus 5e to the x plus 4e to the x? That's going to be 0 as well. So absolutely the sum of those also will make 0. So not only are those two functions individually solutions, but the sum of those is also a solution. Now there's one more thing. Not only that, but any multiples of those two would also be solutions. Here's what I'm saying. We'll call this check 4. And by the way, this is the final check. Check 4. I'm saying that any multiple of that first solution, e to the 4x, plus, from our combination here, any multiple of that second function, e to the x, is also a solution to the differential equation. Here's how I know. The derivative of this will be a times 4e to the 4x be to the x. The second derivative of this will be 16a to the 4x be to the x. Now, just a quick check here so you believe me. What we're claiming is the second derivative minus 5 times the first derivative plus 4 times the function itself do indeed make 0. Let's check it out. The second derivative is 16a to the 4x plus b to the x. There's your second derivative. Minus 5 times this first derivative, 4a to the 4x plus b to the x, plus 4 times the function itself, plus 4 times a to the 4x plus b to the x. Does this indeed make 0? I hope I'm still on the screen. Let's do a quick check. It's the same thing that you've seen here, We're just now multiplying it by a factor of a. Look, 16a to the 4x minus 20, 5 times 4 is 20, a to the 4x, 4a to the 4x. Put them all together, you got 0. Or, look at here, you have a b to the x minus 5b to the x plus 4b to the x. Having a multiplier of b is still going to combine those things and make 0. So absolutely 0 equals 0. So not only individually do these two functions solve this differential equation, their sum solves the differential equation, but also any multiple of each of those. So a to the 4x plus b to the x. This is our solution to this second order homogeneous differential equation with constant coefficients. Now you might see, I hope you see, in a given situation, let's say b was 0 and a was 1. Well, then we've just got our first case of y equals e to the 4x. Or if a was 0 and b was 1, we have our first case of just y equals e to the x. But any multiples and any sum of those is also solutions. So how we will get all of those is through some initial conditions. We would have to know some initial thing. The initial value problem in this second order case, initial value problem, they'll have to tell you y double prime minus 5y prime plus 4y equals 0, and when y at 0 is like 2 and y prime at 0 is like -1 or something, they'll have to give you those initial conditions so you could determine the specific solution with the given conditions. But in general, here in black is the solution to this particular case. Now, go try one on your own. See what happens. Maybe 2. Go do it.